Okay, before we start, can I please get confirmation that you guys can hear me? Unfortunately, my camera is not working today for some reasons, and it is glitching out the Zoom and causing the session to end and that. So we're just gonna do audio today. So just confirm that you can see my screen, which I think is frozen, but I'll reshare that in a second, and confirm that you can hear me clearly. Perfect. Okay, so assalamu alaikum and good morning, guys. Welcome back to grade 10 maths by Inspired Teens, where in today's lesson we are going to be continuing and finishing hopefully the section of exponents, inequalities, and equations. Hopefully we can start some trick today. We just have solving quadratic equations by factorization, as well as solving unknowns in the denominator. Okay, equations with denominators. Some of you might have been messaging me this past week for some questions for help. I apologize. I did not have the time to reply. It's been a bit of a chaotic week, as I'm writing as well. So yeah, next week I'm suspecting the same thing because I am writing. So it's going to be a bit hectic. So I apologize for that. But yeah, let's hope I can get to everyone soon for those questions that you guys do have. Okay, so let us start with some questions. So just to revise, last time we did something called literal equations, okay, where we had to make something the subject of the formula. Okay, now let me just get these memos. That would be great. 1 second. We have okay. So firstly, yeah, hopefully we can start right today. Okay. So I'm just trying to think. Give me 1 second. I just want to see. I will reshare my screen in a bit. Okay, so we did algebraic expressions. We did trigonometry. So we actually don't have to spend too much time on this because, yeah, we already did screen sharing nonsense. We already did factorization of trinomials, right? So what I'm going to do is I'm just going to go through some examples and maybe do like one like this, okay, which is just basically a practice of exponential, which I'm sure we did quite a few of anyway. Okay, so yeah, so we can talk about this question. Okay, so we did factorization. I think maybe it's just quadratic equations, which is most of what we didn't discuss, but it's fine. We can do it here. So we did this, right? We did algebraic expressions and we did quadratic expressions, right? The difference between an expression and an equation is basically an equation has an equal to sign, and you have one left-hand side equal to the right-hand side, and you can solve for a variable in that equation. Okay. However, an expression basically doesn't have the equal to sign, and it's just a few terms. It could be a polynomial with many terms. It could be a binomial. It could be a monomial. Okay, that's just expressed with no equal to sign. Okay, like this. So in this case, they want us to factorize the following fully. So here we have trinomials. Okay, we have a trinomial and we can do trinomial factorization. So remember with trinomial factorization, I open up my two brackets. Okay, my second sign in trinomial. Okay, so actually before that, my first term determines my first two factors. So the only factors of x squared are x and x. And then my second sign determines the signs in my brackets. One is plus, one is minus. Okay, we've been through this. And then the last term determines the factors that need to add or subtract together to give me the middle term. So what I can see, I'm going to do quickly, is 6 and 7, right? Because 6 times 7 is 42. And then I can say 7 minus 6, basically. So positive 7 needs to be the biggest one, because positive 7, negative 6 gives me positive 1x. Okay, so in that case, right, that's factored. That's the final form. This is factorized fully. X plus 7, x minus 6. Okay, but now what happens when we have this? So originally, let's just think, here we had 3x squared plus 5x minus 2 is equal to 0. So this was the original trinomial. Let's just double check. Yeah, this was the original trinomial. Okay, and it was equated to 0. So now we have a trinomial equation. We have a quadratic equation. So in that case, first step, you factorize into your brackets. And after that, the simple step that we're going to learn or remind, if for those of you already know, is basically that you need to equate each bracket to 0. So you're going to take 3x, because now you see the question is different. The question is no longer factorized fully. The question is what? Because it's an equation, they want us to solve for x. You need to get a value for x. Okay, so now once you do that, once you factorize, you equate each bracket to 0 and solve for x accordingly. So you're going to say 3x minus 1 is equal to whatever's on the other side of the equation, which is 0, or the other bracket, x plus 2, is equal to 0. So you equate each bracket to 0. If you have a product of two brackets equated to 0, you can equate each factor to 0. Okay, then you solve accordingly. So 3x is equal to positive 1. Divide both sides by 3. X is equal to 1 over 3. Or take x to the other side. X is equal to negative 2. So x is equal to 1 over 3, or x is equal to negative 2. So that's what we do. Essentially, that's what we're saying we do. That's how we solve it. Okay, so you take it that one step further to solve for the variable by equating each bracket to 0. Okay, instead of just factorizing. Okay, let's look at an example like this, which we've done before. Okay, so what was I going to say? I totally forgot. But either way, this is an exponent example. Now, what we want to do here is, remember, when you have an unknown exponent, okay, let's just write it out, I guess. When you have an unknown exponent, you always want to express both sides of the equation with the same base. Okay, when you have an unknown base, you want to express both sides of the equation with the same exponent and solve accordingly. Okay, so here we have an unknown exponent. So I want to represent both sides of the equation with the same base. So what I can do in my calculator is I can take the shift fact of 7 to 9. Okay, so I say 7 to 9 is equal to shift fact. And I get 3. 3 to the power of 6. I get 3 to the power of 6. So obviously that is not 1 over 3. It's not the same base as 1 over 3, but it is very close. We can convert 1 over 3 to a base of 3. So we can convert 1 over 3 to a base of 3. How can we do that? Because remember, in the denominator, it is currently 3 to the power of 1. I can take any power to the numerator by flipping the sign. So I can actually change this to 3 to the negative 1 over 1. Instead of having to 1 over 3 to the positive 1, I can have it to 3 to the negative 1 over 1. I flip it, I take it to the numerator, and I make it negative. So it becomes 3 to the negative 1. So 3 to the negative 1 to the power of 3x plus 3. But now you might be thinking, okay, it's still, okay, is it not the same base? It still is the same base, but 3 is not alone as a base. We want to get rid of our negative 1. Now, if we remember rule something of exponents, here we have a power, which is negative 1, to another power, 3x plus 3. So in that case, I have a power to a power. And what I do is I can multiply those powers. So negative 1 times 3x plus 3. So it essentially becomes 3 to the negative 3x minus 3 is equal to 3 to the 6. When your bases are the same, you may cancel them. And you may just work with your exponents. Negative 3x minus 3 is equal to 6. Negative 3x is equal to 9. X is equal to negative 3. Correct. Okay, so I hope that makes sense. But yeah, we're not going to do these examples. These are just factorizing. These are grouping. Yeah, grouping. And I think the last one is difference of 2 cubes or something. Okay, but nevertheless, we can then continue, I guess. Let me just double check something. Okay. So yeah, you guys can practice those. I'll leave the memos for them. Let's move on to this, which is steps for solving unknowns in the denominator. Okay, so basically we have a complex fraction, a really complex fraction with linear and quadratic terms. So highest power 1 and highest power 2. Okay, in our denominators. So we have our denominator is x minus 2, 4 minus x squared, and x plus 2. Okay, so again, a complex fraction where we are adding fractions. Okay, we are adding fractions and we have unknowns and it's an equation. So we need to basically solve for x. But how do you add or subtract fractions? You always need to do LCD. Always, always, always. Okay, unless, of course, it's already the same denominator. Okay, how do you multiply fractions? How I like to remember it is in a straight line. What does in a straight line mean? It means numerator times numerator, denominator times denominator. So the new answer is the numerator times the numerator over the denominator times the denominator. How do you divide fractions? You don't divide fractions. You tip and times it. So you flip the second fraction and you multiply them. Keep the first one the same, flip the second one and multiply them. Obviously, then you refer back to how to multiply fractions there. Okay, now that's done. Now let's look at the steps that they mentioned to us. It says factorize denominator, apply the sign change rule if necessary. State restrictions, multiply every term by the lowest common denominator and solve for the equation. So let's have a look here. Just one more second. So it's 10. Let's get these open. Okay, so here we have again a complex fraction. So we want to do LCD. Okay, we can't do LCD until we factorize all the denominators completely. So the one that's left to factorize is the middle one, because these are in their simplest form. We cannot factorize them any further. We can factorize the middle one, however. So this we're going to leave. Now, how do we factorize 4 minus x squared? Someone tell me, how do I factorize 4 minus x squared? Dots. Okay, so let's do it. Let me just think. Okay, yeah, sure, we could do it and then we can come back. Sure. Perfect, right? Dots. So remember dots, a squared minus b squared is equal to a minus b, a plus b. Okay, that's dots. That's how we calculate dots. So I'm going to end up with 2 minus x times 2 minus x, 2 plus x, sorry. Okay, because square root of 4 is 2, square root of x squared is x, is equal to 6 over x plus 2. Now, when I'm identifying my common factor, when it comes to complex fractions, okay, I have to identify the exact same bracket. So for example, here I have x minus 2, there I have x plus 2, okay. However, here I have 2 minus x and 2 plus x. So they are upside down, okay. So what we could have done is we could have went back and did the sign change, okay. Alternatively, you can do the sign change here to just be a bit more complex. Let's just think. It's the same thing, okay. So remember sign change, you can change this sign. So instead of that being a plus, I change this to a minus. And then you add another negative there. So I can add a negative in the denominator, whether you add it to the numerator or denominator doesn't matter, but I want it in the denominator. So I can change my 2 minus x to x minus 2. Okay, this guy here, 2 plus x, that can just simply rewritten as x plus 2 because it's plus. Okay, so I could apply a sign change that way. Alternatively, I could have applied it here already and said minus x plus 3 over x squared minus 4. Flipped it around because it becomes positive x squared and negative 4. So it becomes x squared minus 4. And then once you do dots from there, you'll get your answer. However, here, this is perfectly fine. So we'll take it step by step. 3 over x minus 2 is minus. I'm still keeping that minus. X plus 3 on top divided by, and now I can take this negative in. Remember, it's multiplication. Okay, so I can take this negative in. This becomes x minus 2. And I'm going to rearrange it. Instead of writing 2 plus x, I'm going to write x plus 2. Just to arrange it like everything else. This is equal to 6 over x plus 2. Now, many people get confused. Like, how in the world do you find the lowest common denominator between these fractions? It's really simple, okay? It's like you should treat each bracket or factor, each factor or bracket like a variable. So let's just say we assign x minus 2 to y. Okay, and this is also y, and this is also, and then we can assign x plus 2. Let's assign x plus 2 to x. So this would also be x. Okay, so if we have to rewrite it in terms of that, I'd have 3y minus over xy, I guess, is equal to 6 over x. Now, maybe this is a bit more simple because now your lowest common denominator, okay, should contain each variable. Okay, this is a rule that I'll tell you. Or bracket, and I'm going to remind you that we're going to refer to a variable. We're going to refer, we can treat the bracket just like any other variable. Okay, so it should contain the LCD, the lowest common denominator, should contain each variable or bracket with the, I'm just trying to think, pretty sure it's the highest. respective exponent. Okay, now that fancy English sounds fancy, but basically what it is saying is if I have 2 over xy minus 3 over x squared yz plus 5 over y cubed xz or xy cubed z. Okay, this is important to understand, so listen carefully. So if I want to get my LCD, my lowest common denominator of this term, you can follow this understanding that the lowest common denominator should contain each variable. So here we're dealing with singular variables, not brackets. Okay, with the highest respective exponent. Respective here is just indicating for each variable, whichever is the highest exponent for each variable, you will use that exponent. So we look at, here we have how many different exponents in every denominator? 3. We have x, y, and z, x, y, and z. And what are their highest exponents? So if we consider x, between the 3 that appear, what's its highest exponent? Its highest exponent is 2. So what in our lowest common denominator, what are we going to choose for x? We are going to choose x squared. Then we consider our other variable, which is y. So with y, what is its highest exponent? It's cube. So we're going to choose in our lowest common denominator y cubed. Then we consider z. Okay. With z, what is our highest exponent? It's 1. So we're going to choose just z. This is for our lowest common denominator. So you can do it like this, where you write it under a denominator immediately. Okay, this is how I honestly prefer to do it. It's much faster. And then you make the changes accordingly. So you're still going to write your 2 minus 3 plus 5. Okay, but we can't just write them as is. We have to make our changes. The reason I write it all under one denominator, that's why it's called lowest common denominator. Okay, that's why it's called lowest common denominator, because it's common between each term. Okay, because it's common between each term, exactly. So they're all going to have the same denominator, right? So to go from x to y, so then you ask yourself, how did you get from this xy denominator to x squared y cubed z? So in that case, you are missing what? You can ask yourself, what are you missing? Let's just create some space. Okay, what are you missing? You already have 1x, so you're just missing 1x. You have 1y, but it's y cubed, so you need to multiply by y squared, and you have no z. You have to multiply by x times y squared times z. So what you do to the top, what you do to the bottom, you do to the top. So you multiply that guy by what's missing as well. And here you're going to have 2x y squared z. Let's look at number 3, or the second term. How did we get from this denominator to that denominator? Because remember, we're changing the denominator on top to the denominator at the bottom. So we need to analyze, okay, what did we do to the bottom? Now we need to do it to the top. So the x squared is there in both, so I don't need to multiply by any x squared. However, y, it's y cubed, so I need to multiply it by y squared. Z is already there, so it just needs to be multiplied by y squared. So what I do to the bottom, I do to the top, and it's going to still, you keep the minus, and I'm going to multiply it by y squared. Then let's talk about this guy. So how did I get from this denominator to that denominator? X became x squared, so I need to multiply it by x. I multiplied it by x. Y cubed became y cubed, so that's like multiplying it by 1, but it's the same thing, so there's no need to. And z is z, so I don't need to multiply it by anything, so I'm basically multiplying it by 5. It becomes plus 5, I keep the 5 the same, plus 5x. Okay, so I just wanted to show you LCD in terms of variables, and what do I mean where you choose the highest exponent. In this specific case, yeah, we're not going to simplify further, but that's how you do it. Okay, so let's look at this example again. So yes, like I said, in this case here, where we just replaced everything with x and y, because like I said, the brackets behave exactly like variables. So you're going to, in this case, my lowest common denominator, yeah, obviously we need to create a different one across the equal to sign, okay? Just be careful of that. So here it's going to be a multiplication, multiplication of the variables. So you need, it should contain each variable with the highest negative, highest respective exponent. Here we have two different exponents, x and y. So the highest exponent of x is x. The highest exponent of y is, it's x to the 1. And the highest exponent of y is just y to the 1. So just y. And that's my LCD, xy, xy. How did I get from y to xy? I had to multiply by x. What I do to the bottom, I do to the top. So this becomes 3 times x. Okay. Minus still stays the same. How did I get from xy to xy? Multiplied by 1. It's the same thing. So nothing changes there. Please put brackets either way because this is a negative and then this is a binomial. It's a term with more than one term. A term with more than one, an expression with more than one term, sorry. Okay, then we're done on the left-hand side. How did I get from x to xy? I had to have multiplied by y. So what I do to the bottom, I do to the top. Here I get 6y. Okay, then I simplify accordingly, of course. Actually, when you have an equation, once you have the LCD, you cancel out your LCDs. That's exactly what the LCD is, correct. There's an example I sent to you. Okay, what example you sent to me? Is it like part of the section? Yeah, I think I explained in the start. Sorry, I haven't been able to get back to you guys. Because it's been a bit hectic on my end. So therefore I haven't been able to answer your guys' queries. Okay, like I said, so once you have the equation, you can cancel the denominator on either side, and then you can work accordingly and you can solve, right? So let's just get rid of this and let's get back to our example. This was just if we had to replace it with x and y, but now we're going to do it the normal way. Okay, so now in this case, you should treat each bracket like a variable, exactly like a variable. So we'll make this a bracket, x minus 2, x plus 2 to the power of 1, to the power of 1, to the power of 1, to the power of 1. They all don't have powers. Sometimes you will have powers, but right now they're all to the power of 1. Okay, so in that case, right, using our constant understanding that we just learned, it will make it a bit easier. Okay, so now we have x to the minus 2, x to the minus 2, x plus 1. So we have to identify each different type of bracket and make the lowest common denominator a product of those brackets with their highest exponent. So the different types of variable, I have an x minus 2, appears twice, and I have an x plus 2. The highest exponent of x minus 2 is just x minus 2 to the 1. So my denominator is going to be x minus 2. That's the first bracket or variable. Then we talk about the next type of bracket, which is x plus 2. Its highest exponent is also 1. So my denominator is going to have to include x plus 2. My denominator is going to have to include x plus 2. Now I'm done with LCD, so I need to write it on this side of the equation as well. Okay. Now I need to, whatever I did to the denominator, I need to figure it out, and I need to do the same thing to the numerator. So let's see, from x minus 2, how do I go from x minus 2 to x minus 2 times x plus 2? I just multiply by x plus 2. What I do to the bottom, I do to the top. And that's how I get my new numerator, which is going to be 3 into open brackets x plus 2. Now, how did I go from x minus 2 to x plus 2? Sorry, x minus 2 times x plus 2 to x minus 2 times x plus 2. That's the same thing, right? That has all the terms already in its denominator. So it's like multiplying it by 1. So I'll just put whatever the term is. Please use brackets because the negative is going to affect these. Okay. Then here, how did I get from x plus 2 to the new one? This is definitely not x plus 3. It's supposed to be x plus 2. How did I get from x plus 2 to that? I had to multiply by what's missing, which is x minus 2. And I get 6 open brackets x minus 2. Before we continue, let's make our life easier. Whenever you have solved for the lowest common denominator in an equation, on both sides you have the same denominator, you can cancel it out. You can get rid of it. Because it's almost like you multiply both sides by that denominator and it falls away. You cannot do this in an expression. Please do not do this in an expression. In an expression, meaning if there's no equal to sign, you cannot do this. You will have to always keep that denominator. Even if you find the LCD, you can't just get rid of it in an expression. In an equation, yes, you can. So now we open up the brackets and we simplify. So we distribute 3x plus 6 minus 1 becomes minus x minus 3 is equal to 6x minus 12. Okay, let's group like terms. So I'm going to have 3x minus x minus 6x is equal to minus 12 minus 6 plus 3. 3x minus x is 2x. 2x minus 6x is negative 4x. Minus 12 minus 6 is minus 18. That's minus 15. So if my calculations are correct, we're supposed to get negative 15 over negative 4 is positive 15 over 4. And we are indeed correct. Okay, so I hope that made sense. Do not confuse with that guy. Okay, let's do this one more example. We'll try and go a bit quicker through to it. So I have x minus 3. It's a very similar example. Okay, so since it's a very similar example, actually, I want you guys to do it. So you guys do it. And so I think you keep the negative and multiply by positive 1. Where is it? Yeah, no, you don't do that. You don't do that. Don't do that. Because whenever, just think of it, whenever you have a minus, okay, and like a fraction, this is a perfect example, is when you have a fraction, right? Whenever you have a minus in a fraction, you're gonna have, and in your numerator, you have a term with an expression with 2 terms. So binomial x plus 3. Remember this negative, okay, applies to either the numerator or the denominator. Okay, so always just put brackets. Always. This negative, it's like negative x plus 3. Okay, negative the whole term. Okay, if this was 7x, okay, when you simplify it, it will become negative 7x, right? That's easily understandable. But when you have something like this, negative x plus 3, it's like x plus 3 is like, it's regarded as like one term. So it's like negative whatever is in the numerator, x plus 3. And the reason we put it in brackets is because it's a multiple term thing. Instead of negative 17x, you don't have to put that in brackets because it doesn't have multiple terms. Okay, so it's negative whatever's in the numerator, whether you have a trinomial, whether you have a binomial, whether you have just a single term. X plus 3 times minus 1. I mean, times 1. I don't understand that, but that is incorrect. Like you don't multiply by positive 1. You have to multiply. If you're talking about this distribution, that's what I understand you're talking about. You will always multiply by that negative 1. Just always put brackets. And then you get this answer. Okay, so like I said, you guys can attempt this question. Maybe I'll try and find one more question. I'll leave the memo for this question, and I'll try and find another question and leave the memo for that in the document as well, so you guys can do it. Okay, let's move on to trig. Look, I'm going to try my best to answer your question where you sent it instead of doing it here, because here we're going to start from the basics. So I'm not sure how high up that question is, whether it's about the basics or whether it's about the non-basics. Okay, so when we start with trig, we're going to start with the basics. So I'm sure many of you are either done with trig or, yeah, most of you are, I think, are done with your exam, so you should be done with trig. So let's start with the basics. Okay. So trigonometry, we work with a 90-degree triangle. Okay. Where we have, let's maybe create our own and then we can use the diagram. We'll start here. Okay. So we have three trigonometric ratios. Okay, our trigonometric ratios are these three: sine, cos, and tan that we work with. Okay, so what does sine, cos, and tan mean? Firstly, it has to do with a 90-degree triangle, always. Okay, sine, cos, and tangent deal with 90-degree triangles. Okay, technically not always, but when we work with them, yes. So we have something that you have to memorize. That sine theta, don't worry about theta for now. It's just any angle. We'll just refer to it as theta. Whatever that specific angle is, we just refer to it as theta. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. Now, what is opposite? What is hypotenuse? What is adjacent? For that, we can turn to this diagram and we can analyze. So firstly, it's a 90-degree triangle, and the side opposite the 90 degrees is always known as your hypotenuse. The side opposite the 90 degree is always known as the hypotenuse. Then, besides the 90-degree angle, of course, we have two other angles, A and C. So let's just say we're working with A, and we call A theta. The one that is opposite to theta is called fittingly opposite. The one that's adjacent to theta, now I know there's two adjacent to theta. There's that's adjacent to theta and the other one that's adjacent to theta. But obviously AC is opposite 90, so that naturally would be the hypotenuse. And then the other one that's adjacent, that's the one we refer to as adjacent in a 90-degree triangle. So there's a little, I don't know, mnemonic or whatever you want to call it, acronym or the other one, abbreviation. I don't know what's the correct term for this, but for us to remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's soh ka toh. It's written here. So soh meaning opposite over hypotenuse, ka meaning adjacent over hypotenuse, towa meaning opposite over adjacent. So we can remember those key trigonometric ratios, okay, by soh ka toa. Okay, and they refer to as ratios because we have them expressed as ratios, right? Opposite over hypotenuse, a fraction, is a ratio. Let us talk about the basic cast diagram, which shows the quadrants where each trig ratio is positive. Okay, so I'm not sure exactly how you remember it, but when we talk about a Cartesian plane, the first thing we need to note, that's the first quadrant. That's the second, that's the third, that's the fourth. Okay, so from 0 starts here. We go up to 90. All of that is first quadrant. From 90, we go to 180 degrees. All of that is second quadrant. From 180, we go to 270, third quadrant. And finally, 270 to 360, that is the fourth quadrant. Now, in each respective quadrant, we have a certain trigonometric ratio being positive, okay? And then in others, it's negative. So how I like to remember it is from the first quadrant, so first, second, third, fourth. Many people like it's literally called the cast diagram because of CAST, but there's nothing wrong with learning it as ASAT, ASTC. ASTC. Okay, some of you may learn it as all students take CAT. the subject or the target, I don't know, whichever one tickles your fancy. I'm recommending the subject. So anyway, so what does it mean when we have A in the first quadrant? We are basically saying that all are positive. What do you mean by all? Sine is positive here, cos is positive here, and tangent is positive there. Okay. In the second one, sine is positive, which means what? Cos is negative and tan is negative in the second quadrant. Okay. In the third one, tan is positive, which means that sine is negative and cos is negative. So it's like only sine here, only tan there, only cos there. So when cos is positive, then sine is negative and tan is negative. Okay. On a Cartesian plane, let's express these trigonometric ratios on a Cartesian plane. It's the exact same thing. Okay. Where we have theta, so let's look carefully on this Cartesian plane. We have theta and we have a triangle drawn in with r, which is our hypotenuse because it's opposite the 90-degree angle. Okay. Then we have opposite to theta, we refer to it as y because the length of this line actually comes from the corresponding y coordinate. So you can remember that opposite is y. Then you can also remember that adjacent is x. On the x-axis, whatever this distance is would come from the two coordinates. Okay, so yes, instead it's just basically instead of opposite and adjacent, you use x and y and r for the hypotenuse. Let me see something. Yeah, okay, let's move on. Okay, we're going to move on to, let me just, okay, I see your query. It's a simple query. I'll reply to you today. Okay, so we're going to move on to Cartesian plane questions. Okay, Cartesian plane / Pythagoras questions. Very important for us to understand. It's going to stay with us all the way up until matric. And we need to clarify it now and get all the confusion out and understand it completely. So Cartesian plane questions, you can either draw the Cartesian plane or the Cartesian plane is given. Okay, let's just see that I give you one. No. Okay, sorry. So the steps are as follows. Isolate the trig ratio, number one. Number two, determine which quadrant we are in. Okay, don't know, it's going to make more sense when we do an example. Number three, draw a sketch and use Pythagoras. And number four is, wow, answer the question. Okay, so it says if sine theta minus 2 is equal to 0 and tangent theta is less than 0, determine what is the value of sine squared theta plus cos squared theta without using a calculator or with the aid of a diagram. Now, some of you have lost me in like the first sentence there, but fear not, we shall understand it, right? Let's break it down step by step. And let's answer the question. So the step one is to isolate the trig ratio. What does that mean? Isolate the trig ratio. It just means make the trig ratio the subject of the formula. So my trig ratio is sine theta. Okay. So 3 times sine theta minus 2 is equal to 0. I can take the 2 over to the other side as an addition, which makes it 2. And then I can take the 3 over as division. Where I get that sine theta is equal to 2 over 3. Okay, so I have isolated the trig ratio. Done. First step done. Number two, determine the quadrant. Okay, so this is how you determine the quadrant, right? You're going to use two pieces of information. The first is your isolated trig ratio that you're going to use. Let's use pink. Your isolated trig ratio and the condition that was given. Tangent theta is less than 0. Tangent theta is less than 0. So firstly, sine theta, we have to look at its numerical sign when we isolate it. Is it positive or is it negative? Sine theta is positive. Because it's positive 2/3, our answer is positive. Sine being positive is in which quadrant? Sine being positive is actually in quadrant 1, of course, and quadrant 2. All students take care. Yeah. Okay. So this doesn't tell us which one quadrant we're going to draw it in. It tells us 2 options. That's why we have to use the second criteria given to help us answer it further. Sometimes there's an interval given, okay? So sine, they might say sine theta is greater than is greater than 90, but less than 270 type thing. So this gives you an option of either quadrant 2 or quadrant 3. Okay, so sometimes you might get, it's obviously not in this example, in this specific example, but like I said, yeah, sometimes you're gonna get an interval, okay, and then it will just indicate to you which quadrants they're talking about as well, or theta, sorry, not sine theta, just theta. They give it as theta is between 90 and 270, something like that. Okay, nevertheless, let's move on. So here, tangent theta is less than 0. So this means that tangent theta is negative. Where is tangent negative? Let's just draw up our cast diagram again, which you can do as many times as you like. Tangent is positive in the T and in the A. So therefore, in the second and third, in the second and the fourth, sorry. Okay. Oh, well, I didn't draw it right. So in the second and in the fourth. So one of them is telling us first and second, and the other one is saying second and fourth. Basically, the one that's common between the two is what you're going to choose. Okay, I hope that makes sense. So the first, you need to determine the quadrant. There's 2 steps. You're going to determine which quadrant it is in, firstly, by using your isolated trig ratio. So we isolated sine theta, we got positive 2/3. Since 2/3 is positive, that means sine is positive because the value for sine theta that we're getting is positive. Sine is positive in which quadrants? In the first and in the second. Okay, cool, noted. Now they say tangent theta needs to be negative. So tangent theta is what? Tangent theta is positive in the third and first, so therefore in the second and fourth is where it's negative. Now the quadrant that fulfills both criteria is the one that we're going to choose, and that's the second quadrant, and that brings us to number 3. Draw a sketch using Pythagoras. So you're just going to draw your sketch, and then you're going to use Pythagoras to solve whatever the answer is, whatever the question is, sorry. So we have to draw this again in which quadrant? We determined it in the second quadrant. So how do you draw these diagrams? Okay, you always start from origin and you go where you need to go. So this would be first quadrant, this would be fourth, third, second. So we need to go in the second, so we always start here from origin and we draw a line. Thereafter, we always complete it to the x-axis. No matter where we drew it in, the triangle needs to be completed to the x-axis. So even if we drew it here, down to the x-axis. If we drew it here in the fourth quadrant, up to the x-axis. If we drew it in the third, up to the x-axis as well. Okay, always to the x-axis. So let's continue. So firstly, here is my 90 degree. This is the 90 degree. All right. Then you might see in some diagrams them representing different things as theta. Are we working with theta? Yeah, we're working with theta. So sometimes they call this theta. Okay, mostly actually they call that theta. like the exterior, that's an obtuse angle, the exterior obtuse angle, all the way from 0 degrees, which is why they start there. They'll call that theta, but just know, for understanding purposes, the theta we're working with is the part of, okay, sometimes they might maybe call this theta. It doesn't really matter. The part that we're working with of theta is inside the triangle. We would refer to this as theta. Don't worry about the outside angle, even if they call it theta. For understanding purposes, to answer the question, the angle we're working with inside of the triangle, okay, that we refer to as our theta. So when we talk about opposite, we talk about the blue line, the dark blue line. Okay, that's opposite because it's opposite theta. When we talk about hypotenuse, it's orange line. When we talk about opposite, when we talk about adjacent, it is the black line. Okay. So now what we need to do is we have sine theta. We have the value of sine theta. Sine theta, okay, is equal to 2 over 3, which is opposite over hypotenuse. Sine theta is equal to 2 over 3, which is opposite of hypotenuse. So we have the value of opposite. We have the value of hypotenuse. So we can input those into our Cartesian plane. So sine theta, again, this is the theta we're working with. It's part of that angle, just the part that's inside of our triangle. Okay, this is not theta. We don't work with that theta. Okay, so opposite this theta is blue, and that is, we said, 2. Okay, so that has a value of 2, and it is sine. So the bottom value is the hypotenuse. So the hypotenuse is going to be not h, 3. Now, we are dealing with a Cartesian plane, so please note, you need to consider negative or positive, right? Remember, okay, on the right-hand side of the y-axis, we have positive x values. On the left-hand side of the y-axis, we have negative x values. Above the x-axis, we have positive y values. Below the x-axis, we have negative y values. Okay, so that's important to note with a Cartesian plane. So keep that in mind. So now, as soon as you fill in, so obviously we were given the trigonometric ratio, which we isolated, and that's how we got the fraction 2 over 3, and that's how we got opposite over hypotenuse. Okay, now whenever, jeez, man, whenever you're sort of delayed. Okay, we're going to end shortly, don't stress. Whenever you have a 2 and a 3, sorry, not whenever you have a 2 and a 3, whenever you have two sides of your triangle already filled in, you're going to use Pythagoras, obviously, to get the value of the third side. Always, 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 always. Don't think twice. Don't look at the question. Don't see what the question requires. I mean this. I'm talking about this. Before we get here, once we are in the triangle, always, always just complete your triangle, all three sides. So that's where we use Pythagoras. Remember, hypotenuse squared is equal to adjacent squared plus opposite squared. So if we want adjacent, which is what we are solving for here, we would need to square root the hypotenuse squared and subtract the opposite squared. Okay, how did I get that? Because remember, hypotenuse squared is equal to opposite adjacent squared plus opposite squared. Okay, so now when we want to simplify, we have to take it over. So I need the adjacent. I have the opposite. I have the hypotenuse. I need the adjacent. So I need to leave adjacent alone. So if I leave adjacent alone, adjacent squared, it's going to be equal to, I actually take the opposite over to that side. It becomes hypotenuse squared minus opposite squared. Okay. And then, then I substitute. So adjacent is my unknown. Hypotenuse is 3 squared minus 2 squared. Then I have to square root. Okay, that's how I get it. And I get an answer of 5, I believe. 9 minus 4. I get an answer of 4. square root 5. 235. No, that's a 532. Okay. So yes, indeed, you get an answer of square root 5. Why did you, is this something that can come out in the exams? Yes, definitely something that can come out in the exam, no doubt. Why did you make opposite negative? Shouldn't hypotenuse be negative because it went to the other side? Okay, so basically what I did was, I kind of skipped a step. I took hypotenuse. Okay, so let's not get rid of this. Let's leave it here so we can reference it. Yeah, but I'll show you. I just skipped a step, right? So basically what I did was, so we need to leave adjacent alone. Okay, so we can take opposite over. So it becomes hypotenuse squared minus opposite squared is equal to adjacent squared. Right, that makes sense. All right, that makes sense. Hypotenuse minus opposite is equal to adjacent. Okay, I'm done. That makes sense, right? That's the part, whatever, all right? So all I did was I flipped it. So whatever was on the left-hand side and on the right-hand side, I just flipped it. So I put the adjacent on the left and I put the hypotenuse minus opposite on the right. It's just that I'm used to doing these problems. So I automatically wanted to leave adjacent on the left, just to have my variable on the left. It's easier to work, for me personally, it's easier to work with my variable on the left. And then, yeah, the variable on the right. Sorry, just give me 1 second. I just want to tell these poor grade 11s that we're going to start a bit late. Okay, so I hope that makes sense. That makes sense, right? I hope everyone understands that. So this here, this I can flip, okay? Without changing any signs, I can take everything from the right to the left, and I can take everything from the left to the right. And that's exactly what I did. Adjacent squared is equal to hypotenuse squared minus opposite squared. Okay, it's like having x is equal to y. It's the same as having y is equal to x. Okay, without changing the signs. Okay, I just sort of skipped that step. Okay, so now hypotenuse is always positive. Yes, I was going to mention that. Okay, but yeah, in the Cartesian plane specifically. Okay, let's discuss. So now we got 2 from opposite hypotenuse. That was from sine theta, and root 5 we got from Pythag. Okay, so we've got an answer of root 5, but root 5 is technically not correct. Okay, can someone tell me why? Why is root 5 technically not correct? What should it be? Correct. It's negative. So it should be negative root 5. Okay, because we are dealing with on the x-axis, a value on the x-axis, and it's on the left-hand side of the x-axis. So therefore, it should be negative 5, negative root 5. Okay, if we look at the 2 is on the left-hand side of the y-axis, but why is the 2 not positive? Because the 2 deals with the y value. Okay, and the y values above the x-axis are positive, so 2 is positive. So it works like how you would think a Cartesian plane works with negatives and positives. So yes, this is negative 5. So the x and the y values could be negative. However, in your Cartesian plane, this value of this diagonal hypotenuse is always going to be positive. Is it necessary to say root 5? Yes, the answer is root 5. The answer is not 5. Adjacent is equal to square root. 3 squared is 9. 4 squared is 4. Root 5. There's no simplification to root 5. I think you're thinking about the triangle, because I was thinking about this too, where the hypotenuse is 5. In this case, the hypotenuse is not 5. You're thinking about the 5, 3, 2 triangle. Because there's no simplification to square root 5. Square root 5 is not a perfect square. Sorry, 5 is not a perfect square. So, yeah. Okay. So indeed. Okay. So now we're going to finish this. It's fine. Those the grade 11s, they'll start a bit late. They're used to it at this point. Okay. So we fill in our triangle. We understand negatives and positives. Okay. One more thing is the hypotenuse. Please remember, it always is going to be positive. If you're getting a negative for your hypotenuse, something is wrong. This, okay, in your calculation, you're obviously going to get a positive for these, always. Why are you always going to get a positive? Because you're always squaring them. Why are you always squaring them? I don't know. Go ask Pythagoras himself. Okay. So, but when you're putting it into your Cartesian plane, please make sure to note whether you should put it as negative or whether you should put it as positive. That's for X and Y. Never put a negative for 3. Okay, let's move on. Now that we have our entire triangle filled in, we go to this, what they want. So they say that if 3 sine theta minus 2 is equal to 0 and tangent theta is less than 0, determine sine squared. So we used all this information to draw a triangle. Now we're going to determine the value of sine squared theta plus cos squared theta without using a calculator and by using a diagram. So the diagram is done. That's also a hint in this question. You'll see that tells you need to draw up a Cartesian plane. They'll either tell you by aid of using a diagram, or they'll tell you without using a calculator, or they'll tell you both. They mostly just tell you one, but they can tell you both. It doesn't really matter. If they tell you one of them, just know you should do the same thing. So we want the value of sine squared theta plus cos squared theta. Now, where are we going to get the values of sine theta and cos theta from? From the Cartesian plane. So just remember that sine squared theta is basically the same thing as sine theta squared. And cos squared theta is basically the same thing as cos theta squared. So the value of sine theta we can get from the Cartesian plane. Its value is opposite over hypotenuse, which is 2 over 3. So I'm going to say 2 over 3 squared plus cos theta, which is adjacent over hypotenuse. So adjacent over hypotenuse. So it's negative. Please use that negative root 5 over 3 squared. Let's simplify this. Here I'm getting 4 over 9. You can square the numerator, square the denominator. Here I am getting negative root times negative root 5 times negative root 5 is just 5 over 9. So this simplifies to 9 over 9, which simplifies to 1. Okay, I hope that makes sense. Okay, cool. So let's end it there because obviously we are extremely late already. You guys can attempt this next question. It's very similar, of course. It just has an interval instead of like telling you one of the trig ratios are negative or positive. So you guys can feel free to attempt it. We will do it in the next lesson. And then we'll continue with whatever else we need to continue in. Okay, here, this is what you wanted to do, Mr. Mohammed. I will reply to your messages after 1. And I'll explain it to you. But yeah, perfect. Thank you guys so much for attending. I hope you guys have a good week of school and you're having a good holiday. Sorry to disturb your holiday with maths and tuition. For those of you who are fasting and Muslim, Ramadan Mubarak. Yeah, I will see you guys next week. Same time, same place. Thank you guys. Jazakallah khair. Assalamu alaikum and goodbye. Same to you. Same to you.